Marcelina, rudi nyumbani. Sasa si uangalie kidogo dogo. Na hii yangu leo inakaja. Marcelina, rudi nyumbani uone watoto. Nimehangi. Am I okay? Director. Niko sawa? Iko aje? Ati nimehang? Aje sasa na mimi kama na move. Si ndio nasonga. Wewe ndio nasonga. Wewe hutaki kuniona. You don't want to see me. You don't want. You don't want to see me. Muscle. Oh, kila kitu iko ready. No. Welcome to live chat. Remember to guard your privacy. Well, sasa najua lazima niangalie nini time yenye ya gari unless nataka niende ile hivi alafu nianza fresh. Sasa ni mambo gani? Angoje. Turun. Hello. Halo. Ni wakati wa sayansi. Halo. It is science time. Science time. We're gonna start our lesson. We're gonna start our lesson. Halo. Ni wakati wa sayansi. Halo. Ni wakati wa sayansi. You guys, hey, you. It's now time. It's time to start our science lesson. Listen. The time is here. We are to start our Yeah, guys. I'm almost starting today. We are tackling the grade 9 topic. And that's a biology topic. Yeah, I want to start. Hey, Megi, hey. Can see umefika, umedonjo. Nice. Can see the guys are now streaming in. The guys are streaming in. Today, I want us to look at the grade 9 topic, and that is on the nutrition in plants. The autotrophism. Autotrophism, that is a process in which plants gain nutrients. how plants get nutrients. Yeah. Oh, Maggie, it was a TV. So you saw me live. Hey, naona shame. Can see you saw me in the TV. That's nice. That's nice. That's nice. Yeah. Yeah, ambia wale ambao wanataka kuingia, wale ambao hawajalala waingie. They want to look at something smart. That is the autotrophism, nutrition in plants, grade 9 topic, living things and their environment. Yeah, that's a grade 9 topic where we talk about the leaf. Talk about the leaf. Yeah, the process in which plants make their own food. We shall look at the leaf. We have the external parts of the leaf and the internal parts of the leaf. There's external and the internal structure of the leaf. That is what we're going to look at today. I know you have already tackled that one. Yeah, most of you, wherever you are, I know you have tackled the structure of the leaf, the internal structure of the leaf, the external structure of the leaf. So for me, it's just to go and do something, just going and polishing as we prepare for the KJSEA next term. When you're a grade 9, wherever you are you ready? Very few days are remaining for you to do your KJSEA exam, for you to do your national exam. So prepare. Remember, when you talk about the leaf, the structure of the leaf, yeah, this is paper 1, section B. Yeah, you'll get some questions in section A and others section B. So as a grade 9, it's good for you to prepare well. And today I want to take you through the grade 9 topic, and that's about the leaf. That's about the leaf. How the leaf is used in making food for the plant. Can see Kasioka, where are we writing some notes? Kasioka, I can see you there. Yeah, Kasioka, welcome. Welcome. Yeah, I say that anything personal, you can side chat me. Just side chat me, then we shall talk. Yeah, if you have my number, you can see Kasioka. Nice. I can see my people have joined. My good people, they are there, ready to be scientists, ready to tackle science. Hi, you can see the Dolet. Hey, at XX Dolet. Hi. I can see you there. So we are ready. I want us to look at the living things and their environment. And that one, we look at the nutrition in plants. There is something called the autotrophism. I know you are able to look at it, and you have what we call the heterotrophism. Heterotrophism is how animals obtain nutrients. Yeah, obtain their nutrients, while autotrophism is how plants obtain their nutrients. Now, you get that plants make their own food. Plants make their own food through the process called photosynthesis. Plants make their own food through the process called photosynthesis. Now, photosynthesis, you get that it takes place in the leaf. And this is the main part that we look at in grade 9. The main part is the leaf. Yeah, today I'm tackling the biology part of grade 9. The biology part of grade 9 for those who don't know. Yeah, you understand that integrated science, it has the three components. It has the chemistry part, the biology part, and the physics part. Yeah, very soon I'll be tackling the physics part. Yeah, more so physics part grade 8, that's the pressure, how to calculate pressure, and also I'll be tackling the mirror. Yeah, how to work on the mirror, the curved mirror. Yeah, we have the concave. Yeah, all those mirrors, the parabolic mirrors. We shall look at them. We shall look at them here. So never miss our lessons. I say that our lessons will be 3 times a week. We shall be having a lesson on Monday, Wednesday, and Friday. All of them starts at around 7:30 in the evening. Yeah, 7 ama 7:30. Kichelewa sana ni 7:30 in the evening for 1 hour. Tukienda 1 hour, tutakuwa tumesoma vizuri na we are ready for KJSEA. As you prepare for KJSEA, today I'm seriously tackling the grade 9 topic. So grade 9 is where you are, wherever you are, as you enjoy at home, as you enjoy your holiday, remember that the days are tickling. The watch is tickling and waiting for you. Yeah, waiting for you. So never get tired. Let us move together until we finish our lesson. We finish everything and we do well in KJSEA. When you pass, I have passed. I'll be a very happy one. Cooked. I can see you have XX Dole saying cooked. Okay, I said we shall be starting always at 7:30 in the evening. That is Monday, Wednesday, and Friday. Monday, Wednesday, and Friday at 7:30, or sometimes I'll start at 7 or 7:30. So always by 7:30 be ready. Kaa chonjo na ujuenge kwamba kutakuanga na science. We shall be looking at science. And some days I'll be bringing you live mathematics. Yeah, it's random topics of mathematics. Random topics of science, not mathematics. Yeah, some days I'll bring mathematics, but not now. For now, tusome science kwanza. Then kuna siku nitaanza pia kuleta maths. Yeah, I'll bring mathematics more so weekends. Takuwa nawaletea mathematics live. So we can start. I talked about photosynthesis. And I said photosynthesis is a process in which plants make their own food. That is the one we call the photosynthesis. Yeah, there's a what we call autotrophism, and I say this is how plants obtain their nutrients. So in your various schools, you learn that plants make their own food in the leaf. The leaf is a part that mainly perform photosynthesis. The leaf is the main part where plants make their own food. That is the leaf. So in grade 9, we are able to look at the external structure of the leaf, which we have the parts of the external structure of the leaf, and we have the parts of the internal structure of the leaf. So mainly the external structure is just there for you so that you can know how the leaves look like. Like we have the parts called the lamina or the blade, we have the midrib, we have the petiole, we have the veins, we have the leaf margin, and you have the leaf apex. So you get that the lamina of the blade is the flattened surface of the leaf. Yeah, that one gives you the surface area, the top part of the leaf. That's the one we call the lamina or the blade. That's the lamina or the blade. Then you have the part that now hold the leaf, the stem, that's the petiole. Then you have the leaf margin, hapo kando, the outer outline of the leaf, that's the margin. Then you have the midrib, hapo katikati ya leaf, you have what you call the midrib. And then you have the anterior tip of the leaf, that is the leaf apex. So sometimes they can talk of how a leaf is adapted, the external parts, these external parts of the leaf, how they are adapted, so that they are adapted to help in photosynthesis. How are the external parts adapted to help in photosynthesis? Now, when they ask you that, when we talk about adaptation, you have to know. Now, we have the lamina. How does the lamina look like? It is broad and flattened, the outer part. Why is it broad? When they ask you about adaptation, how is it adapted for photosynthesis? You can say it is broad and flattened to provide what? Large surface area for absorption of light. That is what we look at. Anytime they talk about adaptation, when they talk about adaptation, how is this adapted for this? How is the external parts adapted for photosynthesis? You must be able to know. If they are talking about photosynthesis, you have to be able to know the external parts, these external parts of the leaf. What are these external parts of the leaf? And how are they adapted? Lamina, we have the part called the cuticle, that top part. The top part kabisa, ako kenye kako smooth, kako transparent, mainly that it is transparent. Na inakuanga pia ka waterproof. Ukitoa kwa leaf hivi, unapata it is waterproof. That one is the one we call the cuticle. We shall be looking at the leaf, mainly about those parts. Tutaziangalia sana. Yeah, the stomata, how is it adapted? So today's lesson, mainly I'm going to look at the internal structure. That's the main part, the internal structure. Now in this internal structure, mainly I look at the chloroplast sana. Nitaangalia sana chloroplast because that is where now our lesson is going to be focused mainly. Our lesson today will be focused mainly on the chloroplast. But I want just to give you the overview so that you can see. Yeah, we have looked at the external parts. I want us to look at the internal structure, just the overview of the internal structure. Then after that is when now we shall move deeper on the chloroplast and explain the process of photosynthesis. That is what I want us to look at. Now, get ready. Yeah. Kama hujakunywa maji, take your water, drink, be ready, ka chonjo, ka macho. Usilegelege, usingizi kikuja, piga teke. Usiwe mtu wa kulegea legea. So be ready so that we move together. Now, the internal structure of a leaf. When you look at the leaf, from the internal part, the internal part, you can, by the way, as you continue being there, like the show. Yeah, when you enjoy the show, you can like it, and even you can comment. As long as you comment something good, you follow the guidelines of YouTube. That is, we are here together as a family, and we are here so that we can learn together. Ukiona kuna mahali nimepita kidogo, you are free to ask. Sometimes if I don't see your chats, you can even chat me offline. You can even get me. My number is there on the bio. You can get me and we can talk through WhatsApp, through what. Yeah, if you have any question, you can get me and we shall learn. So that my main aim is for you to pass your academics, for you to pass your assessment. Nowadays we talk about the EE. Okay, we shall look at the characteristics of images formed by mirrors. Good. So Andrew, we shall be looking at that. So probably next time we can look at the physics part. That's on Friday. Yeah, so that we look at the mirrors. We shall look at them. Now, let me continue the internal structure. The internal structure of a leaf. So together the leaf, it contains the upper part, which you have the cuticle. Then as we move inside, we have what we call the epidermis. We have the upper epidermis and the lower epidermis. Imekuwa covered namna hii. We have the cuticle hapa juu. Okay, it is near, that's nice. Okay. So we have the upper epidermis and we have the lower epidermis. Then now we have what is inside there. So we have the cuticle, then the upper epidermis. The cuticle is now thin, is a thin layer. Then you have the epidermis. Now this epidermis, we get that it is the one that contains the guard cells. It contains the stomata and also contains the epidermal cells. There is things we call the epidermal cells. Epidermal cells, it contains the guard cells and also it contains the stomata. Epidermal cells, the guard cells, and the stomata. That one is the epidermis. So that epidermis, the way it is like that, it contains the epidermal cells, it contains the guard cells, and it also contains the stomata. So you get that this epidermis is the one that secretes the cuticle and protects the inner tissues of the leaf from any mechanical damage. That is now the epidermis. From the epidermis, we now move to the one we call the palisade mesophile layer. Palisade mesophile layer. These ones where we have the arranged layers, the packed. These layers are arranged, the cells are arranged vertically. Yeah, they are arranged vertically and they have numerous chloroplasts. This is the place where we have most of photosynthesis taking place. Yeah, hapa sasa ndio kuna the site of photosynthesis, the main site of photosynthesis. You can be asked maybe in an assessment or maybe in KJSEA or any assessment you will do. You will be asked, what is the main site for photosynthesis? That is the palisade mesophile layer. Palisade mesophile layer. This is the main site where photosynthesis takes place. This is the main site. And it contains numerous chloroplasts. Utapata hizo chloroplasts ziko ndani ya nini? Ya hizo cells. The cells are there. Okay, pardon, I have said that we have the palisade mesophile layer. Palisade mesophile layer, this is the main site of palisade mesophile layer. Palisade mesophile layer, this is the main site for photosynthesis. Main site for photosynthesis, where photosynthesis takes place mainly because it has very many chloroplasts in that place. In those cells, they are vertically together, closely packed together. Inside there, we have the chloroplast. Mingi sana. Chloroplast. Yeah, very many chloroplasts. Yeah, the chloroplasts are the one that trap light. We shall look at that. So you get that it has very many. So this now is the main site of photosynthesis. Then after that, we have what we call the spongy mesophile layer. Now here we have the air spaces. Tuko hapo na something called the intracellular air space. Hapa ndo unapata sasa kunakuwa na nini? Kama kuna spaces hapo, it also gives room for exchange of gases. Remember, Carbon dioxide is responsible for formation of food. During photosynthesis, we use what? Carbon dioxide. And oxygen is taken out as a byproduct. Oxygen is taken out as a byproduct. So that means that during photosynthesis, we use carbon dioxide. But during the process, oxygen is released and will be taken out as a byproduct. That means that plants make their own food during daytime, not at night. Daytime is when plants take in carbon dioxide. So they take in carbon dioxide during the day and take out oxygen as a byproduct. So we have the spongy mesophyte layer, the one that have the space where you can have the exchange of gases. Now still in the spongy mesophyte layer, we have something called the vascular bundle. The vascular bundle, the one that now contains the xylem and the phloem. It contains the xylem and the phloem. Xylem is the one that transports water and mineral salts from the soil all the way from the roots coming to the photosynthetic cells. Then phloem, it transports the manufactured food from now the photosynthetic cells all the way to all parts of the plant. That is now xylem and phloem. Now, if they ask you about adaptation, how are the internal structure adapted? The same way I've said in the external adaptation, how are they adapted for photosynthesis? Epidermis is transparent, it is thin. Why? To allow light to penetrate through the leaf. That is how when they ask about adaptation, how is it adapted? How are the internal structures adapted? How are the internal structures adapted for photosynthesis? You now state these parts. We have talked about the epidermis. We have talked about the palisade mesophyte layer. How is it adapted? It has numerous chloroplasts. It is packed and it has numerous chloroplasts. Why? For what? So that it can be able to trap a lot of light used during photosynthesis. Yeah, so this is how you're supposed to explain adaptation. How is it adapted? Spongy mesophyte layer, it has intracellular. Okay, yeah. Now, epidermis is also transparent, but the cuticle is thin layer on top. Good. So, spongy mesophyte layer, how is it adapted? It has the intracellular space that allows exchange of gases. So, this is how when they ask you about adaptation, you look at these parts. Look at the parts, explain. Parts, explain. Now, let us now move direct to the chloroplast. The chloroplast. Chloroplast, and that was the part that I wanted mainly to look at, the chloroplast. The chloroplast, you'll get that this is the part that contains the stroma. It contains the grana. It contains what we call the thylakoid. It contains what we call the starch grain and lipid droplet and the membrane. And there's something called the lamellae. Now, these are parts of the chloroplast. Teacher, the spongy thing, that is, I've talked about the spongy mesophyte layer. Hey, what's wrong with it? That's where we have the air, the ultracellular space where oxygen can move out. There is exchange of gases in the spongy mesophyte layer. The spongy mesophyte layer. Now, let's look at chloroplast. Chloroplast, you have said it contains the stroma. So we have the membrane. The membrane is now the outer layer. The outer layer is the one we call the membrane. So it has the two membrane. You'll get that it has the two membrane, it has the inner and the outer membrane. Yeah, mainly this is just for protection and give shape to the chloroplast. Protection and give shape to the chloroplast. That's the one we call the membrane. The one we call the membrane. Now, inside the chloroplast, we start with something called a thylakoid. Thylakoid are just disc shape. We have the disc shape, the one we call the thylakoids. These are now the one that contains the photosynthetic pigments. Thylakoid ndio inabeba nini? Hiyo sasa inabeba the chlorophyll. Let me speak like that so that you understand well. The one now carrying the chlorophyll. So you get that this chlorophyll is the one that traps sunlight. It traps sunlight. The chlorophyll traps sunlight. And it is found in the thylakoid. It is found in the thylakoid. Now, thylakoid ni kamoja. When they are numerous, when they are many, tunazita nini? Atuzita now thylakoid, tunazita grana. We call them now grana. Ikiwa mingi. Kamoja ni thylakoid. Mingi ni grana. Then, this grana, when they are joined together, different groups, we call them now granum. We have the granum, we have the grana. Then, you'll get that now they are connected with what we call the lamellae. Connected by what we call the lamellae. And then you have the liquid part. The liquid part, this is just a liquid part where we shall have some reaction there. We shall talk about it. Hii inaitwa nini? The stroma. We shall look at the stroma. Yeah, the liquid part, the one we call the stroma now. And then you have the starch grain and the lipid droplets. So this is now how photosynthesis takes place. Photosynthesis. This is now how it takes place. We have the two stages of photosynthesis. Tuko na what we call the dark stage, that is stage 1, and then you have what we call the light stage. Dark stage and the light stage. So the stage 1 is light stage, sorry. The stage 1 is the light stage, where we need sunlight. There we also need chlorophyll. Chlorophyll must be able to trap the sunlight. Then, after that, we shall also need what? We shall also need water here. Remember, we have chlorophyll, we have water, we have the carbon dioxide, and we have the light. Those are the conditions, and others are raw materials. Now, during the light stage, it occurs in the grana. Light stage happens in the grana. So what happens is this. In the light stage, which is the first stage, this is the first stage of photosynthesis. This one takes place in the grana, where we have what? Chlorophyll. Grana, tumesema ikiwa moja, ikiwa tu kale kanika moja ni thylakoid. Then it comes na kuwa granum. Then zikiwa mingi na kuwa grana. So on the grana, in the grana is where we have what? Light stage, which is stage 1. Now, these ones, you get that the chlorophyll will trap sunlight. Chlorophyll will have to trap the sunlight. After trapping this sunlight itakuja. So it will now be formed into what we call the adenosine triphosphate. That is ATP. This energy, ATP, is energy that will be used in the one that will be used now in dark stage. Remember, we call it dark stage. That means if it is dark stage, we don't need light. That dark stage, we shall not need light there, but we shall need energy. Remember, light is also a type of energy. Light is a type of energy. So we shall need energy there. So since we shall need energy, we shall use the ATP that will be formed in stage 1. The one formed in stage 1 is the one that will be used in the dark stage, and that one is adenosine triphosphate. Then, so now in this light stage, we shall have now this energy, the light energy that you get from the sunlight. Yeah, what forms ATP? I have said this is just you get the light energy is converted energy from the sun. Energy from the sun is converted but it is trapped by the chlorophyll and then converted. Remember, energy cannot be made; it can be converted. So it is converted to form a chemical energy, the one we call the ATP. That's adenosine triphosphate. Adenosine triphosphate. It's just energy from the sun that is now converted. It is now converted to form ATP. So you get that this light energy is the one that now is going to break down. It is now going to split water. Remember, water is hydrogen, 2 molecules of hydrogen and oxygen. So it will break that water through the process called what? Photolysis. It breaks through the process we call the photolysis. So as it breaks the hydrogen and water, we shall remain with hydrogen and oxygen. That is what will remain. We shall have hydrogen and we shall have oxygen. So you get that the hydrogen will be used now in the dark stage. Hydrogen is now going to be used in the dark stage. Oxygen is now going to be taken out as a byproduct. Sometimes they can ask you a general equation of what happens in the light stage. So that one you just write water. Water, it is being split. You get light energy. So when you split that water, you'll get hydrogen ions plus oxygen gas. Hydrogen ions plus oxygen gas. So oxygen now becomes a byproduct. It now becomes the byproduct. So it can either be used by the plants. Remember, we shall be using also oxygen during germination. It can be used by the plants, or it is removed out. It is removed so that you can breathe in the oxygen that is removed. So from there, now we have the hydrogen. This hydrogen now, it will now have to move to the dark stage. It will now move to the dark stage. Now, in the dark stage, what we now have in the dark stage, we shall now have what? We have now the hydrogen and what? And the carbon dioxide has not been used. It has not been used. So it is now also going to the dark stage. It is also going to the dark stage. Photolysis, that is the nice Nial. Water is separated through the process called photolysis. Now, in the dark stage mainly it occurs in the stroma. I've said this one happens in the stroma. Light stage happens in the grana. Light stage, grana. Dark stage, stroma. Dark stage, it occurs in the stroma. So you get that in the stroma, where we have now the dark stage, what happens is the hydrogen that was now separated from water in the light stage, it is now coming here to join with the carbon dioxide through now a process called what? Carbon dioxide fixation. Carbon dioxide fixation. It is now going to react the two to form what we call carbon dioxide fixation. And when they combine, you will get what? That's now where we shall get glucose and water. Carbon dioxide added to hydrogen ions In the presence of ATP, here we are using which energy? ATP, adenosine triphosphate. That is the energy that we use here in the reaction where we have the carbon dioxide plus hydrogen ions. And here we shall get glucose plus water. So water here is also taken as a byproduct. Here we also have water removed again as a byproduct. So when it is removed here, this water that is used, that is here, you will get that this water can now also be splitted and we shall have oxygen coming out again. Shall have oxygen now coming out again. So the glucose that is removed here, the glucose, this one is the one that you'll get, it can either be used by the plants. It can be used by the plants during respiration, or you'll get that it is also converted into starch and stored. Kuna mahali kulikuwa na starch granule. When you look at the parts of the chloroplast, kuna mahali kuna starch grain or the starch granule. Starch grain or starch granule. So that one, the starch grain or the starch granule, is now where we get glucose in excess. Now, thylakoid membrane. Now, we don't have thylakoid membrane. We have the membrane and we have the thylakoid. A membrane is the outer part of the chloroplast. Thylakoid is the one that will form the grana. So it's a part. So we don't say that we have thylakoid membrane. We say you have the chloroplast, and the structure of the chloroplast contains the membrane and it contains the thylakoid. So if they ask you about for light stage, I said we have thylakoid in the light stage, and we have there's where we shall have the grana. Thylakoid will form the grana, and the grana are the ones that the place where we shall have what? Light stage occurring. It will occur in the grana. So if they ask you about the general equation, you shall have the carbon dioxide plus hydrogen ions in the presence of ATP, where we shall have the glucose and water. Shall have the glucose and water. Then in the later stage of dark stage, the later stage is where we shall have now the carbohydrates, the lipids, the proteins. Yeah, they will be formed. Regardless of the plants, because we have the leguminous plants, they'll have to produce what? The lipids. Well, the leguminous plants, they contain proteins. Yeah, we have the proteins. We shall need the proteins. So that one now depends. It depends. So mainly that is what is us to look at today about the chloroplast, so that we are prepared about the chloroplast. And you must be able to know this chloroplast, how do we, because we have now these conditions. We have the conditions that are they are conditions necessary for photosynthesis. How do you realize that actually there is this condition there? Mainly the starch. If you are doing an experiment, maybe you are using the iodine. How do you test for starch? As you prepare as a candidate, you must be able to know, how do you prepare for starch? Yeah. As a candidate, you must also know, how do you prepare for chlorophyll? How do you know that actually this condition is necessary for photosynthesis? How do you know that actually there was what? Carbon dioxide. Carbon dioxide is necessary for photosynthesis. Those are the experiments that as a grade 9 you must be prepared with, because you never know. This year's the paper 2, practical paper, 10 marks. They can bring you a question on photosynthesis. That is 10 marks. Are you ready to handle the 10 marks? They'll ask you about the starch. They'll ask you about the importance of iodine. They'll ask you about why should you leave the leaf in a dark room for 48 hours. They'll ask you about why should you maybe place the boiled leaf in a methylated spirit. The purpose of the controlled experiment. Do you know the controlled experiment? If we talk about controlled experiment, do you know it? Those are the things that as a candidate, you must always be prepared. Be prepared. Paper 2 is usually, somebody is asking, why should we leave a leaf in a room for 48 hours? That is meant to discharge. To discharge. When you are doing an experiment on testing starch, the first thing, leave the leaf in the room for 48 hours. That is to discharge. You are making the leaf to use the starch that was there. That glucose, the food that already was made, should be used first. Then you can decide now you want to cover the leaf, or you want to test the carbon dioxide, or maybe you want to test. So you have the controlled experiment, this is the side, and you have the leaf that you are using the experiment. So that one, you must be able to know. That is usually paper 2. That's a paper 2 question. Where we use the variegated leaf, you must be able to know why do we use a variegated leaf. And also, you must know the importance of photosynthesis. Why should plants undergo photosynthesis? Why should they undergo photosynthesis? You must also know about that. So, my good people, yeah, for today's lesson, I want us to stop there. It's already at 8. It's already 8, and mainly our lesson will be going for 1 hour. Yeah, importance for photosynthesis, that's good. We shall be, those ones, you are supposed to know they are good food for the plant. Yeah, one of them is food for the plant. They undergo that so that they can make food for the plant. Also, when they make the food for the plant, it means also you as a human being, you can also eat the food, and then also provide oxygen during the process. You shall have oxygen being as a byproduct. You can use the oxygen, and also it reduces the carbon dioxide in the atmosphere. Carbon dioxide in the atmosphere. And then you have the source of fuel. Yeah, those ones. Those are the things. So any other thing, what you do, you can chat me in my channel here, or you can chat me if you have, you can get my number, the bio, then you can chat me. We can continue learning science and enjoying all about this science. Yeah, so when they ask about okay, Maggie. Now about venation, that's how the plants, they have the veins. Now how the veins are arranged, how they are arranged. So up to there, back to you, my people. I've said on Friday, usikose, ingia mapema, tusome mapema, ili tuweze kujuana na kujua mengi kuhusu sayansi na tuweze kupita mtihani. Yani vyema sana tukipita mtihani na tukiwafurahisha pia wazazi wetu ambao wanatulipia karo, na tunajua kwamba now on Friday I'll be tackling physics. I'll be tackling physics. Yeah, physics, any part random. I've told you probably, God willing, can be tackling the pressure in physics. So my people, ensure that you are well, Naona watu wanaanza kulia, kuna wale wanalia about physics. Never worry unless things don't go well, but if things will move on well, tutangangana na physics na tutaipita vizuri sana. Physics are very easy subject. Yeah, it is very easy. So don't worry. Yeah, as long as you practice, physics is only about pressure, about the mirrors, and about the sources of energy. So nothing more. Hakuna kitu ngumu pale kwa physics. Tutaanza kwanza polepole. Tutaendelea polepole kwanza, tutaguzaguza polepole, then tutaiva. So msijali, with us here, with me, together with you, when we are here, we shall continue learning together. So back to you, my people. Thank you so much for today's lesson, and I can just tell you bye-bye. We meet on Friday. Same time, same place, maybe with the good news, not the same things.